We have already seen about the geometrical parameters of the fabric and how they have to be tested, and today we are going to see about some of the aesthetic and the comfort properties of the fabrics like air permeability, fabric stiffness and drapability. So, all these factors are very important and essential in any apparel fabric. Actually, as per the consumer's view, beauty and comfort are the most desirable qualities for a textile material to be appreciable by the consumer. One among them is the drape, a very important property of the fabric which is related directly to the aesthetics of a textile material. It is not only essential in the selection of textile material for the apparel industry, but also for the design of various garments by the designer. This plays a very vital role. In fact, the properties of the drape will depend upon the structure, the yarn type, the fiber content as well as the finishing treatments that are given to the fabrics. And when we take about the stiffness, the second aspect, it is one of the components of the drape, and this is nothing but the resistance to bending or flexural rigidity, because this is also an influential factor for the aesthetic appearance. And another factor which is more important for the comfort is the air permeability, which is a measure of how well a fabric allows the passage of air through it. Research has led to many types and developments of instruments for the testing of all these factors, where it has started with manual and now we are in the digital world where the textile testing instruments have become digital. The objectives of the present day's lesson is about to understand the importance of all the factors like fabric stiffness, drape and air permeability, to know about the different equipment and how to assess the properties, and to comprehend about the testing of these materials using a different equipment, and to also express these tested materials in appropriate measure. Now, let us first talk about the air permeability. As we all know, textile materials can be a barrier or can also be a transporter of either heat, air, moisture, where it travels from one environment to the other. Generally, we know that woven fabrics are produced by the interlacement of warp and weft. So, when the interlacement takes place, there are some voids that are created between these yarns. The volume of these voids, like the size of it, the shape of it, the texture, the arrangement, etc., are the ones which give rise to the air permeability. So, we can say that there is a complex nature of this airflow through the fabric, because the structure of the fabric itself is very complex. So, air permeability of considerable value, especially when we are predicting about the insulation characteristics of a fabric. Now, the air permeability can be measured as the airflow in cubic feet of air per square foot of fabric per minute in a standard system, or as a cubic meter of air per square meter of fabric per minute in the metric system. So, this is not only essential for the apparel fabric, but they also find a lot of use in especially the gas filters, the airbags which are made of fabrics, mosquito netting, parachutes, sails, tentage and also the vacuum cleaners. The air permeability of a fabric is generally influenced by several factors like the type of the fabric structure, the design of the woven structure, the number of warp and weft per centimeter, or we call the thread count, the amount of twist in the yarn, the size of the yarn and the type of the yarn structure. Now, there are some construction factors and finishing techniques which also play a role in the air permeability. So, appreciable effect upon the air permeability is done by all these construction factors and the finishing techniques. Actually bring about a change in the length of airflow path that is created in the fabric. For example, when we take hot calendaring, which actually flattens the fabric during the calendaring process, will obstruct the air from passing through, because the void places are almost sealed by the hot calendaring method. Fabrics with different surface textures on either side sometimes do have a different air permeability because of the direction of flow of air. And as we can also see that as the twist increases, the density or the circulatory density of the yarn increases, thereby reducing the yarn diameter, that means it becomes thinner. The cover factor will therefore reduce and thereby increasing the air permeability. The other way is They may allow more circular high density yarns, like when they become thinner they will be packed so closely that they can also reduce the air permeability of the fabric. Now, before going to how the air permeability can test it, we will also see some of the terms related to the air permeability. Like one is the air permeability itself, which has already been defined. Now, the air resistance, which is the time taken in seconds for 1 centimeter cube of air passing through 1 centimeter square of the fabric under a pressure head of 1 centimeter of water. We have another term called the air porosity, which is almost similar to the air permeability, and according to Skinkel, this can be defined as the porosity of a fabric is the ratio of air space to the total volume of the fabric, which is expressed as a percentage. Now, when we take the measurement of air permeability, there are a number of instruments that have been developed, and let us see one of the instruments developed by BITRA. We call it as BITRA air permeability tester. So, when we take the total instrument into consideration, we can see that the housing of this instrument is on a wooden frame, and on this we can see there are 4 vertical glass prometers which are grouped together, which have a range of 50 to 200, 100 to 900, 500 to 3000 and 1000 to 3000 liters per hour marked on the same glass meter. And each of these has a off and on valve beneath each of these. And when the valve is open, we can see that the flow of air can be passed through it, and it will be possible to measure the amount of air passing through it with the help of a float that is provided in each of these glass meter. Now, there is a fabric clamping unit where it is a circular fabric of 10 centimeters square which is actually used there, and the clamp also has a circular opening of 10 centimeters square with a rubber covering for an 8 feet of the sample. A ring will be activated by the handle which presses the fabric and clamps it to the opening. So, beneath it will be a suction head fixed to the working platform of the instrument, and this also has an opening of the same 10 centimeter square, exactly similar to the clamping unit, and the fabric is clamped in fact between this clamping unit and the suction head. So, the suction head is again in turn connected to the flow meters by a rubber tube. Now, apart from this, we have another manometers, 3 manometers inclined at a particular angle, which are ranging from 0 to 25, 25 to 90 and 90 to 160 millimeters. And the upper part of these manometers is connected to a suction head by a rubber tube and through an overflow glass receptacle, and the lower common is connected to the glass reservoir of the liquid, which is placed behind the housing of the instrument. These manometers help to measure the pressure difference between the two sides of the fabric specimen with the help of water column. Now, how do we test it? The specimen is first taken. After conditioning it, it has to be clamped between the upper clamping unit and the suction head. An airflow regulative valve is closed completely. Next thing has to be done is the level of the liquid is to be adjusted at 0, and now the suction pump has to be started with all the taps closed. Now, one of the regulatory valve is opened gradually using the particular knob given to it, and at a time only one flow meter has to be opened and the rest have to be closed. Now, for example, if the R4, that is the regulator 4 is open, then all the others are closed, and if the flow is less than 30 centimeters per second, then R3 is opened and R4 is closed. So, in this way a suitable range has to be selected. When the specified pressure difference is shown on the pressure manometer, the corresponding air volume passing through the flow meter tube has to be taken into consideration. Now, the second aspect of the comfort or the aesthetic property will be the fabric stiffness. It is the important decision factor for the end users, because most of the parameters generally are there to judge the drape and fabric handling. So, fabric stiffness has a tendency of fabric to keep standing without any support, that is, they are very stiff enough. So, there is one aspect called the bending length, which is the interaction between the fabric weight and the fabric stiffness, in which a fabric bends under its own weight. Hence, bending length can also be defined as a falling length having a particular angle. The degree of fabric stiffness is related to the properties such as fiber, material, yarn and fabric structure. A stiffer yarn makes a fabric very stiff regardless of the type of weave that is being done. Using flexible strands, we can see that the fabrics with a wide range of stiffness can be produced depending upon the type of fabric structure that is done in them. Now, the instrument that is used to test this particular stiffness is the Shirley stiffness tester, which also has a platform, a smooth surface with low friction such as polished metal or plastic, and next to the platform it is supported by two side pieces made of plastic with some index lines engraved on them, inclined at an angle of 41.5 degrees below the plane of the platform surface. At this, the angle f is theta, that is equal to 0.5. A mirror is attached to enable the operator to view both index lines from the convenient position. A scale is supplied with the instrument to measure the bending length, and this scale is graduated in centimeters, which also serves as a template to cut the fabric sample. So, the test is done with 25 mm wide and 200 mm long piece of fabric that is cut along with the template. It is to be cut because we need to test the fabric both the warp way and the weft way. Minimum 10 pieces can be cut both the warp way and the weft way specimens, and they have to be conditioned first, and after conditioning one should see that they should be flat without any creases, and it should be well taken care that they are flat along with the scale. So, actually 4 readings are to be taken for each side, one on one end and the second on the other end, and again reversing the fabric we need to take another, and so the second end of the fabric again another 4 readings have to be taken, and the mean bending length of both the warp and weft is calculated separately, and the flexural rigidity of the fabric in total can be calculated later. Now, the procedure is to keep the tester first of all on a very level surface using some spirit lamps or spirit levels. Now, the test specimen that has to be placed flat on the platform first, and the scale is also gently placed over the fabric, and the scale has to be then gently slided till the leading edge of the test specimen moves away from the scale and bends down till the tip of the specimen is viewed in the mirror, which cuts the 2 inclined lines. The bending length can be read immediately from the scale marked opposite to a 0 line that is engraved on the side of the platform. Now, the sample has to hang for at least 6 seconds before the reading is taken. In case there are certain fabrics which would twist when they would hang on themselves. So, in such a cases the center point of the leading edge which coincides with the plane has to be considered. All the test samples have to be weighed later on, and their length and width have to be measured, and then the areas have to be calculated, and weight per unit area has to be determined from that. Now, when we take the formula for calculating, the bending length is first calculated, which is designated by C, which is L by 2. L means the length or the mean length of the overhanging portion of the material in centimeters, and from that the flexural rigidity G is calculated by taking the weight per unit area of the fabric in milligrams per square centimeter into the bending length milligrams per centimeter. The overall flexural rigidity for both the warp way and the weft way is the square root of the flexural rigidity that is calculated for both the warp and the weft directions. Now, there are certain fabrics which are very limp and which cannot give a satisfactory results by the cantilever test method. So, for such fabrics we have another method called the Hart loop and the Piers loop method. So, here the stiffness of the fabric is calculated in terms of a loop which is allowed to hang on its own weight, and here the strip of fabric end of the specimen of length L is mounted on a clamp in the apparatus, so that the free to hang vertically, and after an interval of 1 second the distance between the top edge and the clamp to the bottom of the loop L has to be measured, and from this we can take the stiffness of the fabric, and this stiffness is inversely proportional to the length L, where the test has to be repeated after the sample is turned over, that is on the wrong side of the fabric. So, for all the test specimens it has to be repeated, and the average has to be taken, and you can take the bending length from this. So, the bending length here is C, that is equal to 1 theta f 2 theta. So, where theta is 32.85 degrees into d by L, where d is equal to again the length of the specimen minus the length of the hanging, and from this we can derive the bending length of the particular fabric. Now, the next important aspect where comfort is a major problem will be about the fabric drape and the aesthetics also. Majorly, people would like to have a fabric to be draped over the body because it gives a very good effect on the person. So, drape is a term used to describe the way a fabric hangs under its own weight, and drape and hand are these two aspects which are very important for the apparel fabric. So, among these, drape is one of the most important property of the fabric, which has played a very significant role in providing a very graceful effect on the garment. And this is also important for the designer, as depending upon the drape of the fabric, the designer has to design a garment, and also it influences the appearance of the wearer. And not only this, good draping leads to a very good fitting factor, and without any undesirable wrinkles or even without any creases on the garment. So, drape measurement is also very significant in the garment industry, and for the fabrics for suiting especially, this possess fewer drapes, and the fabric for shirting and ladies wear should possess a high drape. So, for women garments, drape is one of the important aspect to be considered. Now, there are certain factors that affect the drape of the fabric, especially the stiffness of the fabric is also one of the aspect which creates the drape of the fabric. And we have this drapability as a combined effect of several factors as stiffness, flexural rigidity, weight and thickness also. So, we know that soft fabrics drape well closer to the body, forming good shape, whereas stiffer fabrics drapes away from the body. So, stiffness of fabric itself depends upon the geometrical properties of the fabrics. So, when we make fabrics from very heavy coarse yarns and dense constructions, generally these fabrics do not drape well. Fabrics that have long floats in weave like that of satin can be more flexible, bending is more easy and improves the draping quality. Fabrics that are made from filament yarns with little twist, the draping quality is very good. Finishing agents again can alter the hand and the draping quality as well, especially starching, which gives body and weight and smoothness, but it gives a very stiffness to the fabric. On the other hand, resins can modify the hand of the fabric, which gives a lot many draping qualities to the fabrics. So, as far as bending rigidity is concerned, it is calculated from the bending length and the mass per unit area. Fabrics with low bending rigidity may sometimes exhibit seam pucker and are prone to problems, especially in the cutting out of the fabrics. And this also will pose a little problem to handle on an automated sewing or production line. A fabric with higher bending rigidity may be more manageable during sewing, resulting in a very good seam, but whatever in the molding process, they would cause the problems. So, stiffness and fabric bending are both dependent on the thickness. The thicker the fabric, it becomes stiffer, and all other factors remaining the same will also create a lot of problem in stiffness. Fabrics with higher bending length are stiffer, they lack good drape and lack also the flexibility, and they cannot be used for fabrics where aesthetics is of great consideration, and also at the same time the wearer may not feel very comfortable using these fabrics. As far as drape is concerned, there is a term called drape coefficient. It is a single number with a theoretical maximum of 100 and minimum of 0. According to IS, drape is defined as the extent to which a fabric will deform when it is allowed to hang under its own weight. And drape coefficient, which is designated by F, has been developed to describe the degree of drape and the drape shape. A lower F indicates that the fabric is softer, whereas we can say that if the drape coefficient or the F is higher, the fabric would be stiffer. When we take the instrument for this, we can see that it is a rigid cast aluminum F shaped vertical stand which is screwed to a wooden base, and on the upper extension we see a light assembly where it comprises of a large condensing lens, a hood and a mercury vapor lamp inside the hood. The sample holder is on the lower extension of the stand. So, it consists of a threaded bolt ending in a spring loaded socket which is designed to take the lock in position the stub of the specimen holding plate. The test specimen to cut for this would be a 25 centimeter diameter, which is cut according to the template given along with the instrument, and in the center of the specimen we have to make two cuts of 5 millimeters which are diagonally opposite to each other, and this will facilitate for easy placing of the specimen on the holder. Then we also need to have a printing paper or good quality ammonia paper, which is cut into 30 by 30 centimeter square piece, for which the mass per unit area of the paper has to be determined. Now, the procedure or how to test this fabric is, the tester is first placed very firmly on a very level table and it has to be switched on, and generally the vapor lamp would take a little time to glow, and the fabric specimen is first placed between the plates, and holding the stub of the specimen holder assembly, we have to briskly move the holder with the specimen up and down at least 10 times, and each time resting it on a table for a moment. So, this will allow the fabric to have a graceful fold or fold on its own. A square piece of this ammonia paper is first placed on the base of the instrument, and now the stub of the specimen holder is placed or inserted into the socket of the bolt, and the holder is locked in position by pressing it upward, and after this it is allowed to hang for certain amount of time, and at the end of the exposure time the ammonia paper is removed and it is placed in a separate developing box meant for it, where in which we have a strong ammonia solution added at the bottom, and the paper can be removed once the latent is developed on it. Now, both the paper is conditioned in a standard atmosphere and the fabric before testing. So, the drape pattern is cut out of this particular pattern, and then its mass in grams will be taken up or it has to be determined. The specimen is reversed and the drape pattern with another surface is again taken using the same ammonia paper. Now, the drape coefficient F percentage is calculated by the mass of the drape pattern by the mass per unit of the paper by the area of the circle of 25 centimeters diameter minus the area of the circle of 12.5 centimeters diameter into 100 gives the drape coefficient. So, as said earlier, the higher F value indicates a stiffer fabric and a lower F value indicates a smoother fabric. We have seen about the aesthetic and the comfort properties that are required and the means of testing them and evaluating them and expressing them in terms of the relative units.